はい、それではこれより、基調講演の時間とさせていただきます。ミシガン大学、ミシガンデータ科学研究所データサイエンスインスティテュートのジャガディッシュ先生に、時差を超えて真夜中から参加いただいております。ミシガン大学は現在、真夜中の0時43分ぐらいかと思います。ジャガディッシュ先生は、データベースビッグデータの分野の最も高名な研究者の一人であります。データベース分野の研究としましては、データベースをいかに真にユーザーに使いやすいものにするかという研究に取り組まれておりまして、可視化や自然言語による検索、不完全なデータに対する検索などを含んだ幅広い研究をされ、このトピックで ACM シグモドというデータ処理やビッグデータのトップ会議で基調講演をされていらっしゃいます。データを通じて数多くの学際的な協調連携を手掛けていらっしゃいまして、そのうちの一つにはマテリアルサイエンスのためのデータ共有の仕組みでありますマテリアルコモンズというプラットフォームや、それを含んだプリズムスというプロジェクトを手掛けられていらっしゃいました。より最近はデータ活用において非常に極めて社会的に重要な倫理的な側面、データ科学の公正さ、社会的な影響などについて研究されており、データサイエンスエティックスという講義がエド X、コーセラ、フューチャーランなどの MOOC プラットフォーム上で提供されております。本日もその関連でお話しいただきます。講演のタイトルは Data Science Addressing Challenges in University and in Society というもので、ソサエティ 5.0 が掲げるデータ活用による利益をすべての国民が安心して享受できる社会づくりという我が国の目標とも強く関連するもので、多くのことを学べるものと確信しております。またこの講演ですけれども、時間の許す限りご質問を受け付けていただけるということになっておりますので、Zoom のウェビナーの方でご参加いただいている方々は、Q&A を使ってご質問いただければと思います。また同時通訳でお聞きいただけるようにもしておりまして、Zoom 上の地球のマークです、通訳のマークを押していただいて、日本語をお選びいただくと同時通訳の音声を聞くことができます。それでは始めさせていただきます。Okay, so Jagadish Sensei, thank you for being with us again today. So, and I'm sorry that we are already slightly behind. And so, if you are ready, let's get started before you fall asleep. So, Jagadish Sensei, are you ready? Okay. So, if you're ready, please get started.
Thank you very much, Professor Taura. It's my honor to be here today. Thank you, and thanks to you and to Professor Kitsuragawa for inviting me. I was in Japan a year and a half ago and discussed some of the things that we have been doing in terms of a data science institute at the University of Michigan and in the US. When I was here, I talked to you about how we normally think about a human in the loop in this way, where the humans are users of computer systems and they have questions, they have data that they wish to analyze or explore data sets. And what the computer system gives back to them are results of queries, suggestions on what to look for or how to explore, help in terms of how to use the system. And there is a great deal of work in usability of computer systems and specifically usability of big data systems. And this is something that I've personally worked on for many years now. But as big data has had greater impact on society, almost everything that any of us say or do is being sucked into our digital exhaust, and decisions that affect us are being made using algorithms that analyze this big data. These could be things like customized advertising, but this could also be things that affect our lives, like decisions on employment or on criminal sentencing or on whether to give somebody a loan and so on. And so my new picture for human in the loop is humans in the loop create a digital exhaust from their activities. These are sucked into the big data processes, which then in turn impact humans. And so this is exactly the same loop between humans and big data processes, except that in the previous picture, humans were driving the process. They were users of computer systems, whereas here they are subject of the process and they're being driven by the big data systems. So in this context, a thing that has become clear to many people is that there is a need for data ethics. So what are ethics? Ethics are principles that help us distinguish right from wrong. Okay? They're the cornerstone of civilization. And the point about ethics is they give us rules that we voluntarily choose to follow because that makes the world a better place for all of us. So there are many things that we could do that we don't do because that's the rule of society. If we did these things, we would not be good members of society. And so that's the notion of ethics that needs to be there for anybody who's doing big data work. And today, I want to talk specifically about one aspect of ethics, and that is equity. So the question, of course, is what do I mean by equity, and particularly data equity? The closest thing to equity is the notion of fairness. And so let me talk about fairness for a minute, even though it is not the same thing as equity. Okay, but having a discussion of fairness first will help us understand what I mean by equity. So for fairness, the kinds of things that we talk about are perhaps individual fairness, which means you treat individuals without prejudice, so that if there are two individuals from different groups, maybe different race or different ethnicity or different gender, if their performance on something or their attributes are the same, then we say we will treat them the same way. And that's individual fairness. There are notions of group outcomes. So this is to say, is the success rate or the selection rate the same for men and women? If one group has much higher rate of success or admission or promotion or whatever is the good outcome that we're looking at, then a starting assumption is there must be something wrong with the process. And so there has been a lot of work on notions of fairness, and basically the notion, the reasons why algorithms in data-driven systems can become unfair is because training data sets may not be representative of the population. It's possible that the societal environment has changed, so the past population is no longer representative of future population. It could be that there are confounding processes. There are many, many reasons why things could be wrong. And so there's been a lot of excellent technical work on algorithmic fairness over the past less than 10 years. And when one thinks about deploying big data systems, particularly since much of what I'm saying may seem as if it is critical, I want to point out that human beings also have many biases. No human is perfectly fair. Each of us may have the best intentions, and we may try to be as impartial and as fair as we like. But we know that we are all subject to all kinds of subjective notions, all kinds of biases. That's how our brains work. And so we note that if an algorithm is biased, it's usually much easier to measure. If a human is biased, they'll explain it away. They'll make excuses. And so it's much harder to prove that a human decision was colored because of some bias. And so whereas algorithms can be biased and can be biased in really horrible ways and can intensify biases, this is not to say that they're bad inherently. This is like if humans run into each other because they're walking and not looking carefully, it can be unpleasant, but usually nobody is going to get hurt very much. Now you put human beings in cars and they have many advantages. They can go long distances, they can go in comfort, but if they're driven carelessly, people are going to get killed. And so that's the same kind of idea that one needs to apply to big data. One has to make use of all the advantages of big data, but in the process, one has to make sure that people are driving big data systems in a responsible way so that the outcomes are what we would like to see. So with that basis in fairness, I want to talk about the difference between fairness in terms of equality, which is how people often think about it, and fairness in terms of equity. And this cartoon shows on the left-hand side, equality, where there are these three people who are trying to see this baseball game. And as you can see, the person on the left doesn't need the box to stand on. And the person on the right doesn't have enough of a height with one box. So the same three boxes, if distributed unequally, as in the right-hand side picture, provides equity, where all three are now able to see the game. So what does this mean in terms of how we operate? So one example that there has been a lot of discussion and debate in recent years in my university and in other American universities has to do with standardized exams. So we have historically considered things like a GRE exam as a standard test, and scores on this test are used to admit students to graduate school. Now, one may think that that's a very fair thing to do. After all, the students who are able to do best on these tests must be smarter, they must know more, they must have worked harder, whatever. They're the brightest students because they scored the highest. But what has been shown fairly conclusively in many studies is that there is a very strong correlation between GRE scores and how wealthy the family is from which the student came. And the reason is that sort of commercial test preparation makes a big difference in these tests as they're currently constructed. The same kinds of differences, the same correlation between wealth and exam scores is not observed, at least not observed to the same extent, if you consider things like grades in local school exams and things like this, because that's spread over a larger period of time. People usually prepare less. And so there isn't a benefit of test prep that goes to people from better off backgrounds. And so we have a system that was producing equality, but was inequitable in that poorer kids who didn't have the benefit of test prep would end up with a lower score and therefore less likelihood of admission. So this kind of notion of equity is something that we're trying to apply to big data systems broadly. And I want to mention 4 types of issues that we are studying. So first is representation equity. So it turns out that underrepresented groups, marginal groups, minorities, are often suppressed historically in the data record, and for various reasons. So, this past year, of course, we have all suffered across the world on account of COVID-19 and the various problems that it has caused. And so I'm going to say a few things about the COVID-19 challenge and how we're dealing with it in my institute and so on. But right now, I want to give you a few COVID-19 driven examples to show how equity and data equity plays a role when one tries to understand this pandemic and its spread. So if you look at testing for COVID-19, especially earlier, there were substantial disparities in the availability of testing. People who were better off were more likely to have access to testing than people who are poorer or members of minority groups. And then furthermore, there's a question of, do people want to be tested? And people want to be tested if there is some benefit to them from testing. And if people are suspicious of testing because of historical reasons, or if people say, well, even if this test shows something, I'm not going to do anything about it. It's not going to affect me in any way because I can't afford to get medical care. They're not going to get tested. So for both of these reasons, if you look at the collected data, and if the collected data is based on testing for COVID-19, what we will find is that in the data set, there will be substantial undercount of COVID-19 prevalence for, say, African Americans. Now, as a data scientist, if I'm going to go do some data analysis, a common mistake that people will make is to say, well, I have this data set and I have a good data set of COVID-19 in testing. And so I'm going to go with whatever these test results show. And the problem here is that before you even start your data analysis, you have to say, is my data set representative? And do I have appropriate equitable representation for the various groups that I'd like to see? A second question that one has to address is a notion of feature equity. So if there are certain features that matter, we should make sure that those features are appropriately recorded in the data set. So a thing that, there was a lot of controversy in the US about the higher prevalence of COVID-19 for minorities. And while that was considered, and there were hypotheses about why that might be the case, it turned out that the data actually were not as helpful as we would have liked them to be. And the primary reason for this is that there were only some institutions and some locations where the patient's race was actually being recorded as part of medical treatment. Now, if you think about it, typically if you go to a doctor, the doctor isn't going to ask you what your race is, or isn't going to necessarily note on your record, on the medical record, what your race is. That there isn't a good reason under normal circumstances to say that should have been part of standard medical care practice. However, if you're going to address some public health issue, and this public health issue has to address racial disparities, if race is not recorded in the data, then it has to be imputed. We have to figure out what the race might be based on whatever other secondary or indirect hints we might have in the data record. And this is error prone. This can be expensive. And for all of these reasons, our data with respect to racial disparities in COVID-19 occurrence and treatment is actually very poor. The next question of equity is access equity. So once there is some data or some data products, some results of analyses that have been created, there's a question of who has access to it. Usually there is some data owner, and the data owner may have spent time and resources, incurred costs in developing this data set, and may hope to leverage this for future benefit. And this turns out to be the case even when these data are not private. So if a state government owns some COVID-19 data that they have created, they may have all kinds of competition with other states, or worries about possible misuse, or no incentive to get legal approval to share, and so on. And so we often end up with small and fragmented collections of data without the global benefits that one could get through larger data sets for more standard analyses, higher quality analyses, or for people to be able to benefit from others' experience that's maybe similar to their own. Finally, I want to talk about outcome equity. And the point is, in spite of all of our efforts to try to make data-driven systems equitable, society is complicated, life is complicated, and we may have unintended consequences after the fact. So, for example, contact tracing is a major public health tool that has been widely used in the context of COVID-19. But once contact tracing is done, there is a question of how these contacts are notified and what people know about who has been infected. And in many places, we have news stories of people who had COVID-19 being stigmatized, being harassed. There were tenants who were evicted from apartments by landlords because they were positive for COVID. And so when there are harms like these that may be possible because of the social situation, we have to be very careful when one says there's a public health need to do contact tracing in terms of how the results of those contact tracing are used. So with this understanding of what we're trying to accomplish in terms of data equity, I want to say a few words about what a data equity system is, because that's what we're trying to build. So if you read newspapers, this is the picture that you'll see of how AI works. You take some big data, you apply this big green AI magic to it, and the results are you get deep insights. And what I showed you on my previous slide may look like a cartoon, but actually, this is a picture from the website of a Silicon Valley company. Basically says the same thing as my cartoon. So this is not the journalist didn't make up the cartoon picture, this cartoon picture from nothing. They write as if this were true because they see things like this that were made up by marketing people for technical companies. So what is the actual picture? So here's a figure from a white paper that I coordinated with a bunch of leading academics in the US a few years ago. And the point of this figure is to show that the big data ecosystem involves a pipeline with many steps, as you can see here. And analysis and modeling is actually only one of these steps. And AI techniques, powerful as they are and exciting as they are only applicable and used in this one step. This is an important step, and it deserves a lot of attention and care. However, in terms of performance or in terms of equity, in our case, in terms of whatever issue one might be wishing to deal with, one has to think about how things could go wrong at every point in this pipeline. And so our notion is there are challenges that must be addressed in terms of equity at every stage of this pipeline. And the kinds of questions that one has to see is at the time of data acquisition, what data sources are we using, who's represented, what is being measured, what do we owe to a person in the data, are there privacy requirements, are there no repurposing guarantees. When we do any kind of data cleaning and integration, we recognize that real data are messy and dirty. But if you're going to do data cleaning, that is itself based on some assumptions. So for instance, if you assume missing values are missing at random, that may not be a valid assumption. And so if that kind of imputation has to be tested. Representation choices matters. If you're going to bucketize values, your bucket boundaries may matter. And often what the questions you can ask depends on what you've chosen to represent in the data set. Then you do the modeling and analysis, and afterwards, there's the whole question of result presentation. You have to explain what data were used. And you have to say, what will make humans trust algorithmic decisions? So once we worry about all of these, we try to solve them. And systems that implement these solutions are what we call data equity systems. Now, our initial work in this is to say, well, solutions aren't going to be complete. They're not going to be perfect. We're just going to make some initial attempts at solving some piece parts. And a few of the piece parts, for instance, that we have worked on are efficient ways to identify coverage of a data set and trying to find holes in the data for combinations of attribute values. So if you don't have enough entries, then you might have difficulty with the results that you get. We have developed a notion of nutrition labels that we can associate with data sets, similar to the nutrition labels you get on packaged foods. Not giving you all of the information, but giving you some summary information that tells you something about the fitness for use of the data in the data set. We have looked at how large a label is required to be able to understand, to be able to reconstruct data sets in terms of estimating counts for attribute value patterns, for instance. And it turns out that fairly low error rates can be attained even with quite small labels. We looked at fairness in ranking and found that small changes in the weights that we apply to various functions that we might be computing can greatly change the results that one obtains. And so one can end up with very different ranked results. I think stability in ranking is another thing that is very important in terms of making sure that you're not getting things because of some artifact in how certain parameters were chosen. And so if you look at the rankings of computer science departments, the reference ranking that was published in one website that this picture is from was somewhere in the middle in terms of how stable it was, whereas there were other rankings that were far more stable and therefore presumably better. Result presentation, if we can have a graph like this, I can cherry pick 2 points like this and say, oh, this is a falling trend line. And when you have these kinds of conclusions that people intentionally draw from the data, trying to spin it in a direction that they would like to, we would like to be able to detect that in an automated manner. And we did some work on that. So we have individual solutions for individual problems. And what we're trying to do is to integrate these into good end-to-end data equity systems. Besides building systems, to be able to get this to be broadly adopted, we want anybody who's learning data science to have an understanding of data ethics in their core curriculum. And for this reason, I have developed a collection of videos in an online course, which was originally on the edX platform, is now also on the Coursera and FutureLearn platforms. And individual videos and case studies here are licensed free for reuse using Creative Commons. So I encourage people to pick and choose any pieces that you like and incorporate them in your own teaching. So the last few minutes, I want to switch gears and talk a little bit about the University of Michigan and how we have been doing data science. So we have a data science initiative, and there's 3 parts to this. There's sort of the compute infrastructure. There is the consultation for students who are trying to understand how to use data science methods. And there is the big picture research, education, partnership types of things. Now, in the big picture thing, when I visited last, our mission statement was this. Okay, our current mission statement has changed very slightly to be this. And I'm going to go back and you'll see that really what has happened is that the word artificial intelligence has been added to the top part and some corresponding adjustments made afterwards. But otherwise, it's the same thing. And so the key point here is in the past 18 months, since I had a chance to speak to some of you in Tokyo, the importance of artificial intelligence has grown, and what we had as a mission of our Institute for Data Science to do preeminence in data science to become preeminence in data science and artificial intelligence. From the perspective of most disciplines, which means the bulk of our university and society broadly, there is actually very little difference between data science and artificial intelligence. Somebody who's a practitioner in computer science may see differences in terms of the specific technologies and methods that are in place. And so I'm not saying they're the same thing at all. But what I'm saying is that from the perspective of a political scientist or a geologist or a material scientist or whatever, the differences are local and distinct, are not visible because there are local differences within fields far away from these. One of the things that we at our institute work very hard try to do is to build interdisciplinary collaboration. And one of the things that COVID has done is made us all work remotely. And so the kinds of things that we used to do in terms of having brainstorming meetings sort of was no longer possible. We'd try to create working groups to try to build up ideas. And it actually turned out that once we figured out the new methodology of working remotely, this has actually been very successful for us. In the pre-COVID days with physical meetings, we used to have to try to, because of the costs and time of people coming together, we would try to have a 2-3 hours, a 2-hour session or so. And, we tried to schedule it as best as we could, and there would be people who would have conflicts and so on. And it was always just one session on some topic as a brainstorming session because we could never get 2 or 3 sessions done. With the Zoom life, things are very different. So we now have sort of settled on a format of 3 one-hour meetings, a few days apart. And we have found that this is actually a very effective way to do brainstorming. Not everybody might be there at every meeting, but enough people are. And if there are some new ideas, giving a few days for people to think about them really makes a difference, and we make much more progress from one meeting to the next. And so we've had a couple of working group series on topics that you see here, and this has worked well for us. With COVID-19 coming on, one of the things that we were also able to do is use some of the mechanisms that we already had in place to do some special COVID-19 related data science funding. And just to give a sense of what we did, our request for proposals, we were able to prepare within a week or two of everything coming to a close. because of COVID. But then within 30 days of the request for proposals being posted, we not only had project ideas that were submitted, proposals that were submitted, we reviewed them, announced funded projects, and started work. And we got 49 proposals from almost 100 scientists across the university. We funded 7 projects that you see here written in pink. And these 7 projects were immediately implemented within less than a year. And many of these have now secured follow-on funding from external agencies and so on. So this has been a very successful program. Another measure is here 4 of the projects that were written up in major media: Washington Post, New York Times, National Public Radio, Reuters News, and so on. Finally, one other thing that the Zoom life has done for us is made it easier actually to collaborate across institutions. So we have set up a new coalition where we joined with 6 other academic data science institutes that you see listed here at the bottom of the slide. And we now have this thing called Data Science Coast to Coast in the US, which is a seminar series. And so once a month, we have one high profile seminar that's at a national level. And it's done remotely and attended remotely, and has very high visibility. And this kind of forum would not normally be possible if people weren't on Zoom, so where distances didn't matter. So under very difficult circumstances that we have all struggled with over the past year or so, we have actually found a few ways to make some progress and actually secure some advantages over what we were able to do before that. So with that, I'm going to wish the best of luck to you in the new endeavors that you're launching today. And I'm going to stop and can take any questions.
So I guess we have time to take a few questions. So are you seeing the Q&A of the Zoom? I read for you. So the first question you got is one of the difficulties that we are facing in using current AI technologies is explainability. So do you have any comments on explainability?
Yes, very much so. I think explainability is really important. And I think explainability is important for the purposes of trust. If you don't understand something, trusting it becomes a question of blind faith. And that's never a good situation to be in. And I think that AI results more explainable at the current time. But one of the things that I would urge you also to think about is explainable to whom. So when many people think about explainability, they think about explainability to other people like us, who are technically sophisticated and want to understand algorithms. And so we may say, well, why did this deep neural net arrive at this conclusion where, why is this particular node lighting up in this network, and try to understand what its weaknesses might be and how it came to the conclusion. That's a little bit different from somebody whose loan application was rejected by the same neural network. They don't care how the neural network operates. The explainability they want is what was it about me that your system didn't like, and why is it that you didn't give me a loan and you gave that other person a loan who I don't think is as trustworthy as me? And that's a fair question for somebody to ask. And, if you have human loan officers, they have some mental model in their mind. And to the extent that they're willing to share that information, they could explain what additional things would be required or why somebody was not a good loan risk. Right? That explanation AI systems have to be able to give. And I think that that's actually a harder thing to do, and requires going beyond developing explanations for technical people.
Okay, thank you very much. And I guess you are seeing the next question on your screen. Can you see that?
I am trying to get to that.
Maybe you want to turn the page of the videos. So it is showing.
I cannot pin that page somehow. I can
okay. So
see it in very small. So sorry.
Okay, so I read it for you. So this is a question about, I guess, about the equity system you described, end-to-end system. So the question was, I understand that equity should be addressed at every stage of big data pipeline, but still a long way remains to establish data equity system, I'm afraid. So can we build a data equity system by simply combining equity consideration at each stage, or should we seek for some new methodology to build data equity system specifically? So would you please give us your thoughts on this issue? So the overall.
Yes.
Okay.
Yes. So I think this is actually a very good question. And I can tell you that honestly, I don't know the answer to the question, but I have a belief. And so my belief is that we have to try, and if all we can do is to address piece parts today, that it is worthwhile to address piece parts. This is how we make progress in so many aspects of technology. At the end of the day, having addressed many piece parts, we may realize that there are issues of system construction that impose some fundamental considerations that we didn't realize. Or there may be some architectural considerations overall that are really important. But if we don't know that yet, I think that addressing piece parts helps. It makes things better piecemeal, and it improves our understanding overall. And so we should do it, even if ultimately it turns out not to be the right thing to do, or not the best thing to do. I mean, even if it turns out ultimately that something else is a better thing to do.
Okay, thank you very much. And I guess so it's a time to finish. So thank you very much again for joining us and giving the talk despite the huge time difference. So you got be now 3P. So thank you very much again.
Thank you. Thank you very much.